Alright, hello everybody, welcome back. I am Joshua Griffin, and today we're going over linked lists, and this is just going to be an overview of them, how they work, the concepts essentially behind it. We will be doing 3 of these videos. The first one will just be on what the heck is a linked list? Why should I care about it? The second one will be most likely on, okay, how do I insert something and remove something from this? What's the concept behind that? And then the third one will most likely be the pros and cons to it. So, linked lists, right? So, a linked list is exactly what it sounds like. It's a list that's linked together. But the biggest thing is that it's not contiguous. So, non-contiguous, which means that it has multiple blocks of memory somewhere, right? So, for example, I could have a block here, a block here, and a block here, right? But they all have to be pointing to each other. This is called a singly linked list. So a single linked list. And a doubly is this. So one is pointing there and back. Okay? That's essentially what that would be. So this is double linked list. Okay? So the biggest concepts that you guys really need to know now is basically these little boxes. This is called a node. Now, a node is comprised of two things. A, which is this. This is called data. This is the data that you're storing. This is a pointer to the next node. So, for example, we have one that's pointing to another one that's pointing to another one, right? The reason why I draw little lines is because this is for data, this is for next. Data, next, data, next. Now, as you guys can see, this does not have another node behind it. Now, the reason being is because this is the end. This is called the tail. This, the first one, should be known as the head. Now, the reason being is because it's the first, the head is the very beginning, the tail is the very last. Now, when you create your linked list, you can keep track of both of them. I only keep track of the head personally because it's a little bit less memory intensive and it's easier on, the coder. So, at the end of the day, the head is this. Each one of these has an address. So, for example, the memory address could be 0x0FAB2. I don't know. Like, that could be the address, right? And then this one, this is holding an address right here. This could be like 0x0AFB4. And so that's what this one is. And then this N could be holding, some random address like 0x0 QZRT, right? Something completely random. And then, that's also, as it turns out, this guy's address. So you guys can see how it's all linked together and they see each other. And that's how you would be able to go from one node to the next node to the next node and get that data and then return it, okay? So essentially what I would do, what I've done is I held a size variable. And every single time I added something in, I'd increment the size. That way I could say, hey, I want to iterate through this. Instead of having to use a while loop and just check, hey, if this is not equal to null, for example, the next of that, just tried to use my finger to erase that. Whiteboards for the win, am I right? So if this is not equal to null, we continue. Otherwise, we stop because this is the tail. As soon as this is equal to nothing, this is the tail. Okay, that's how we would know that that's the tail. Now, at the end of the day, that is a linked list.